I have this exercise here, and it's on page 43 of your class notes. It says the following back-to-back stem plot represents the amount a sample of students spent on their last haircut. Because there are significant differences between males and females, the data was separated by gender. Okay, so first of all, on this stem plot, remember we have this stem, the part that repeats, and then here we have the leaves for the female going to the right and the leaves for the males going to the left. Okay, so we are in one stem plot, we're comparing two data sets. They're related. They're both, what is it? Students spend on their last haircut. So these are the values that students spend on their haircut. And it looks like male haircuts are slightly cheaper than female haircuts. Okay, so we're comparing the two instead of bunching them together all in one set. Question A, calculate and label the 5-number summary for the amount spent on females. Okay, so first, before we actually do the 5-number summary, we have to basically undo this stem and leaf plot. We have to get our original data values back, okay? So it looks like for the females, there were no haircuts that cost in tens. It's cheaper than 20 bucks. There was none. And for the males, if we're comparing, there were 4 haircuts in that range. Now for 20s, we have one person paid 20 bucks, another one paid 25, and another one paid 25. So there were 3 people that paid 20 plus. Then for 30s, we have 35, 37 twice, and 39. Okay, for the 40s, we had 43, 45, and 46. And then for 50s, we had 50, 53. Then we had one who paid 60, one who paid 70, one paid 85, and there is one person who paid 100 for their haircut. Okay, so that's our data. Now, in order to calculate the 5-number summary, we need the minimum, which was 20. We need the maximum, which was 100. And then we need the median and Q1 and Q3. We need those values. Okay, so remember, in order to calculate the median, we need to split out data. Location of the median, n plus 1 divided by 2. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So n is 16. So we have 16 plus 1 over 2. That's 8.5. So our data, our median is located between 8th and the 9th value. So we're gonna go in and grab them. And even though they're not linear, I didn't write them in one line. You understand that they're going like this, from smallest to largest. Okay, so let's grab value number 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 is here, and 9 is here. So our median is going to be between 43 and 45, and that's 44. So for the median, we have 44. Okay, now let's talk about Q1 and Q2. Well, how many values do we have before our median? We have, or below, we have 1, 2, 3, 4, 5, 6, 7. So again, the location of Q1 we have n plus 1, so 7 plus 1 over 2 is number 4. So 1, 2, 3, 4. Now our fourth value is 35. So that's our Q1. Q1 is 35. Now, since our median divides our data set into equal parts, then for Q3, it's also going to be number 4 of the higher values. So 1, 2, 3, 4, 60 is the median. Not the median of the upper 50%. So Q3. All right. So we need, in order to calculate the lower fence and the upper fence, that's where the whiskers stop. We need to calculate our IQR because those values depend on the IQR. So IQR is 60 minus 35, and that will give us 25. The IQR is 25. Okay. So to calculate the lower fence, we take it's the formula for that is Q3. It's Q3 plus, no, that's the upper, sorry. The upper is Q3 plus 1.5 IQRs. And for the lower fence, it's Q1 it's Q1 minus 1.5 IQRs. Okay, so let's figure it out. So we have Q1 is 35 minus 1.5. IQR is 25. Let's calculate. Oh, my calculator does not work. Let's do this one. Okay, so 35 minus 1.5 times 25. And we're in the negatives, we're in negative 2.5. So that's the fence. That's how long would it go if we had more data values on the left side. But look, we don't have any value that's negative. So we're gonna, for this one, we're gonna use the actual minimum instead. So here, when you're plotting the box plot, you're gonna use the minimum instead, 20. Okay, now let's calculate the fence. That's gone. for the upper fence. So the upper fence is the Q3 is 60. It's going to be 60 plus 1.5 IQRs. 60 plus 1.5 times 25. And our,
Professor,
yes,
could you scoot up the paper a little bit, please?
up,
Thank you. Yes.
sure, yes, of course. Yeah, let me know because I don't know how it shows. So we have 97.5 for the upper fence. Well, this value is lower than our max, so we would use this one. All right, so now let's go ahead and actually construct a modified box plot for the amount spent by females. Okay, so for the minimum, we have, well, yeah, let's do the middle part first. So the median is 44. So this is 45. So 44 would be slightly to the left. Okay, 44. And Q3 is 60. So right here. And Q1 is 35. 35 is here. So this is our box, our middle 50%. Now for for our fances, let's mark our fances. So the first fans was negative 2.5. Well, it's way on the left side here. We don't even have, we don't have any values there. So we're not worried about that one. Now for the upper fence, we have a 97.5. So it's halfway between, so 95 and 100, halfway. So our fans would be right here. All right, but look how our maximum value is 100. So our maximum value is beyond that fans. So we're gonna just mark it as a dot. We're not gonna, our whisker does not go beyond the fans, okay? So that maximum value will be just a dot, not a whisker, and the whisker will stop here. Okay, now for the minimum value, we have 20. Well, that's way within the fence because the fence is all the way there on the left side. Okay, so this is our, and then we're gonna connect. Basically, we're gonna connect our minimum value on the left and our fence value on the right. So there you go. And this shows you that it's a skewed data. It's skewed to the right. We have an outlier on the right, which is identified. But we're gonna say, okay, these are all like usual values, and 100 is really unusual. It's an outlier. So your fancies on the box, they identify the outliers. Basically, and like they separate your usual values and the unusual values. Do you guys understand? So on this one, we went, our whisker went to the minimum value because the fans value was way, it was not, our minimum value was not outside the fans. So we used it for our whisker. Now, our maximum value was beyond the fans value. So our whisker goes only to the fans, and then the maximum is just indicated as a point outside our usual range. Okay, guys, do you have any questions about this one?
Yes.
Uh-huh.
The 1.5, where is that coming from?
1.5, that's
Yes.
the formula. because remember we said that in the video here, I was saying that the whisker should not be longer than, oh, you didn't see it. The whisker should not be longer than IQR times 1.5. And we were measuring 1 IQR, half of IQR. So that's that 1.5 times IQR. Okay, and it's in your notes too. Let me see, let me find it. On page 41. See this graph, like, so we have the middle part of your box plot. This distance is your IQR. And then your fences go 1.5 IQR to the right and 1.5 IQR to the left.
Okay.
Right?
Okay.
Do you guys have any other questions? Good questions?
I have a question. So when you try to do the Q1 formula, and if it turns a negative and you don't have a negative on your list, do you automatically use the minimum number?
Yeah. Yeah, but it's not because it's negative and I don't have negatives. You see, what is the fence lower than your actual value is? So if is your minimum within the fence or is it beyond the fence? Whatever,
Okay.
it didn't have to be negative. It could have been positive. Like even if we got 10, let's say, let's pretend that we got 10 positive value for our lower fence value. Your minimum is still not beyond that value. So you're gonna use the minimum. So your decision, basically, your decision is based on, is my value outside the fence or inside the fence?
Oh, okay, that makes sense. Thank you.
You're welcome. You guys, good questions. Do you have any other questions?
I do, Miss Olga.
Sure.
A lot of this is confusing to me. Okay, so on the lower fence, you got, okay, Q1 minus the 1.5, which is 35 minus 1.5, right?
Times 25, you're forgetting.
Okay, okay.
This, when you just put a number next to another number in parentheses, that means, that implies multiplication.
Okay,
Automatically.
I missed that part.
And also don't forget the order of operations. Multiplication comes first before
Oh,
subtraction. So you have to multiply first, then subtract from 35.
25, 10, 1.5. Okay.
All right.
So
Yeah.
why do you use 20?
Okay, because it's within the fence. It's within the fence. Okay. So Kelly, who created the notes for this course, she actually uses the sheep examples a lot. So let's say you have a few sheep. Okay, I don't know. They look like cats, but so you have your sheep here. These are your data values.
Okay.
Okay. Um, and these sheep, there is a fence around them. So these sheep are inside, but let's say there is one sheep that's outside the fence. Okay, So if your minimum value is inside the fans, then you use it. If it's outside the fans, it's a bad sheet and you don't use it. You use whatever's sheep the closest that's inside the fans.
Okay. I think I get it now.
All right.
That's the, so that the sheep that's outside, that's the outlier.
Right. Yeah.
Okay.
Mhm. This is a very unusual sheep.
Yes, it is. And so it's further than the 1.5.
Yeah. So for the modified box plot, you only your whiskers that only go inside the fans.
Okay. So what's the upper fence and lower fence?
Those are your values.
Okay.
Okay. That's 1.5 standard deviation to the left and 1.5, not the standard deviation, IQR. 1.5 IQR to the left and 1.5 IQR to the right from the box.
Okay. I got it.
All right, perfect. Any other questions, guys?
There'll be a video on this, right?
Yes, I did not have time to post it. It was, we have a construction going on next door, and it just trying to record a video is very challenging because of that. But yeah, right after class, I'm planning to do a video on this. Okay, so a couple other things about box plots. I want to show you. All right, so this is page 44 of your notes, class notes. So we're gonna, what are the advantages of the box plots is that you can compare more than just two categories side to side. So in this, for example, in this box plot, we're comparing 3 different vineyards and their prices of wine. Okay, so it says the box plots display case price in dollars of varieties of wines produced by vineyards along 3 of the Finger Lakes. Okay, so question 1 is which lake region produces the most expensive wine? What do you think? I want you to try and answer. You can write it in the chat if you want. Or just say. So which one of these 3 produces the most expensive wine?
The middle one?
Okay. So that would be the most expensive price would be the one on the top, right?
Oh, okay. To the right.
So yeah, for this one, I think it's Seneca or Seneca.
Seneca. So what do the lines in the middle of the in the box inside the box? What do they mean?
That's the bulk of the prices. That's the bulk of your. But they have some very expensive one.
Okay.
Okay, it's not a usual. It's not usual for them. These are usuals, right? It's not
Oh, okay.
for them, but they do have it. Okay, that expensive price. Okay, so question B, which lake region produces the cheapest wine?
The same one, right?
Yeah, because that would be your very lowest point, right? So it's the same one. Okay, in which region are the wines generally more expensive? So here's the thing. If I wanted to purchase a bottle of wine for a gift, if I Seneca would not be a good place to buy from, because let's say I buy the most expensive wine from them, they have a wide range of prices. So the person doesn't know that the wine was expensive unless they Google it and see, how much money I put in, right? So like if I want a gift and that the person knows that we put in money into that gift. So which of these wineries would you choose?
Well, the middle one seems like they sell the most.
Yeah, the bulk of their prices is pretty high.
Mhm.
Yeah, you're right. So, um, Kiyuka? Kiyuka location. Okay. Question D, which region has the largest spread in case prices using range? So remember, range is the from the minimum to the maximum. So the whole
So Seneca.
Seneca, yeah, Seneca um, has the widest range using range spread using range. Which region has the largest spread in case prices using IQR? Remember, IQR is just the length of the box itself. So it's the difference between Q1 and Q3. So when you're talking about IQR, you're looking at only at the box, the length of the box.
So will it be the first one?
Yeah. Mhm. So the bulk of the prices, what is it, Cayuga. Cayuga has the biggest range in prices using IQR. So among the bulk of their wines that they sell, there's still like a big spread among prices. In this the Cayuga, wow, they're pretty close in pronunciation. So Cayuga, they have the bulk of the prices is higher, and like it seems like it's more consistent. They consistently charge more for the wines that Cayuga. All right. So do you guys have any questions about this one? This exam? Okay. So let's proceed to exercise 4. It says the weights of the male and female students in class are summarized in the following box plot. Okay. Which of the following is not correct? So when answering this types of question, which of the following is not correct, you read each statement and basically you address them, you think about them as true or false question. True or false. So about 25, so basically they're asking you which of these is a false statement. About 25% of the female students have weights more than 125 pounds. So where is 125, 28, 100, this is 130, 128 is about here. And it says about 25% of the female students weigh more than. Yeah, it looks right. So this is 25%. This is true. The median weight of male students is about 162 pounds. 162, this is 70, 170, 62. Yeah, looks like this is also a true statement. C, the mean weight of female students is about 120 because of symmetry. Okay. Well, the mean weight of female students, 120, true. And this data looks pretty symmetric, right? The left side is a mirror image of the right side. Yeah, true. Okay, D, the male students have less variability than the female students. Okay, variability means the spread, right? Okay, look at the spread of weight of female students and the spread of weight of the male students. So less is not the right word here, right? So this is false. The spread of the male students, of the weights of the male students is more, not less than females. Okay, so this is a false statement. That's not correct. And let's look at E. It says above 50% of the male students have weights between 150 and 185 pounds. Okay. Above 50%. Let's see. 150, 40, 50. Okay. Yeah, that's Q1. And then 185, this is 190, 185 is here. So that's Q3. Yeah, that is correct. All right, guys, do you have any questions?
Hey, Ms. Philippitz, I have a question for C.
Uh-huh.
When you ask for the mean, you're asking for the average, aren't you? But here it shows the median
Oh,
for males
actually,
or
yeah.
females.
Mhm. Okay, so here's one thing that I don't think I mentioned in this class yet, but it's a very important, point. Thank you for asking that. That's something that we need to address. So when your data is symmetric, I'm gonna write it down. I don't have a page. Okay, I'm gonna do it here. So when your data is symmetric, then mean, median, and mode will either coincide or be really close to each other. Okay, so that's a very important statement. And when the data is skewed, then your mean will be different from your mode because, yeah. So because remember, the median is resilient to outliers, and the mean is not. So whenever your data is skewed, your mean will be thrown off by the outliers. And that's why when we are dealing with skewed distribution, we will prefer median over mean. Okay. And the IQR over standard deviation.
Could you repeat that again?
When we're dealing with a skewed distribution, we'll prefer median over mean as a measure of center.
And okay, and so when you're saying that, what are you? Can you give me an example?
Sure. It's actually, I'll find an example from your notes. Okay, here's an example. Actually, let's go over it right now, because that deals exactly with what we're talking about. So exercise 5, the back-to-back stem plot below gives the bowling scores of male and female participants in the finals of a national tournament, right? So here, again, it's back-to-back. We're comparing females and we're comparing males. So when you look at the data for females, it is normal, right? Like it's symmetric. But when you compare the data for males, look at this, it's skewed. Now, the question that you want to ask yourself, let me ask you, is it skewed to the left or to the right?
To the right.
Skewed to the left.
Oh, for the males, skew to the left.
Yeah, because these values 0, 3, they're going to be on the left side, and that's where the tail is, right? These are the outliers on the left, so it's skewed to the left. Okay, so here, identify the best measure of center and spread for each gender based on the distribution. Then calculate these values and justify your choice of this measure in one sentence. So for the females, the choice of center would be the mean because the data is symmetric. Mean. All right, to calculate the mean value, I'm gonna use my CI calculator. So to enter the values, 230. 9, or shall we use, let's use StuckCrunch because you guys are gonna use StuckCrunch, right? So let's do StuckCrunch for this calculation. So basically what I'm gonna do, I'm gonna unwrap this these data values, and I'm gonna put them into StuckCrunch. So let me open it up first. Okay. All right. So I'm gonna male scores and female scores. Now I'm gonna enter those scores. So for the males, the first one is 240. And the next one is 253. 260. 268. 78. And it doesn't have to be from smallest to largest, because the software will sort it by itself.
And plus, you're just getting the average, right?
Yeah, but you know what? I I could do it on the calculator, but I see that later we're gonna calculate the spread.
Oh, okay.
So yeah, I don't want to do the spread by hand. That would take forever. 287, just entering this data. 299 and 299 again, right? Or 289 actually. 289. Okay, I made a mistake here. It's 289, not 299. There we go. So for the female scores, 8, 9, 2, 238, 239, 240, 242, 248. Please make sure that I enter the data correctly. 250. Proofread, please. Okay, so we got the data in, and let's do graph, a histogram. Okay, so we could do, if you look at a histogram of female scores, do you see it? Do you see the graph, or should I change the?
Yeah, I see it.
Okay. All right, so this is what the frequency distribution of female scores looks like. So it's a little bit skewed to the right, but pretty much it's symmetric. Now, if we do graph for the histogram for male scores, okay, so this is what it looks like. So obviously this data is skewed to the left. It's
Right.
not symmetric at all. The female scores, they're more symmetrical, all right? So therefore for the female scores, let's calculate. We go to stats, summary, columns, and I'm gonna select the female scores for now. And I'm not gonna change any defaults, just go to compute. And it's gonna give us, you have to pick and choose what we want. We set mean is 256.8.9 if we were to round it correctly. And look at the median, it's 256, exactly. Look how close the mean and the median are, right? Okay, and mean calculates every single value. So in case of symmetric data, we're gonna say the mean is more accurate. It's the average, yes. And we're gonna use it for the data female scores. So the calculated value here is gonna be 256 of the mean, 256.9. Okay. For the choice of spread, well, we're gonna use the standard deviation, and see it's already calculated here. So for the standard deviation, we have 14.6427. Yeah, that's the standard deviation. Now, for the males, because their data is very skewed, let's calculate the values. So stats, summary, columns, male scores. Okay, I wanna see, because I already saw that it's a skewed data. So I will need, for the measure of spread, IQR. And the IQR is located right here. So I'm gonna just add it to the list of the computed values. And Here we go. So for the skewed data, let's compare the mean and the median. So the mean is 174 and the median is 278. So that's 4 units apart. Okay. And the standard deviation, we're not going to use standard deviation here because it's a skewed data. We're going to use the IQR 18.
So what is that 18 telling us?
That's telling us that the spread between in the middle 50% of data is 18.
Oh, okay.
The spread of the middle 50%. Okay. So the choice. Do you guys have any questions on StuckCrunch? I'm gonna stop sharing now. We're good?
No, I think we're good.
Okay, perfect.
I thought it was going to be hard, but it's not.
Is somebody talking? Is it a question, or I hear somebody talking, or did you just? All right. Is someone asking a question? All right, so let's continue. So for the males, the choice of center would be median. And I forgot what it was. Let me go back. It was 278. And for the choice of spread, we said we're going to use the IQR, which is 18. Okay, and justify your choice. We choose, okay, so since the data for female scores is symmetric, we use mean and standard deviation. I don't have room here, but vice versa, because the data for the males. Oh, okay. I had to write it there. Okay, and justify your choice. The data for males is skewed, and that's why we're using the median and the IQR. And this is what I showed you in one of the videos. So for symmetric data, we use mean for center and standard deviation for spread. And then for skewed data, we use median and IQR. Okay. Now, one other thing is outliers. How do we identify outliers? When your data is symmetric, then we use z-scores. So any z-score, like if the z-score of your value is well, if your value is more than 2 standard deviations away from the mean, that means the z-score is greater than 2 or less than -2, then it's an outlier, it's an unusual value. And for the skewed data, we use fances in a box plot, in a modified box plot. All right.
Is that, Ms. Olga, is that 2 or more deviations from the minimum or max?
From the center.
Oh, from the center?
Yeah, because remember, your normal distribution looks like this. This is 0 in terms of z-scores, 1 standard deviation, 2 standard deviation.
Okay.
Okay, so everything greater is unusual. And then you go to the left, you have 1 standard deviation, 2 standard deviations. So -1, -2. That's what's unusual. All right, guys, any questions? Do you have any questions? No? Okay. This is it for today in terms of lecture, okay? I do have a worksheet that I wanted to work on in groups. So where is it? Let me see.
Miss Olga,
Yes.
a quick question for you. Are you pulling the exercises from the lecture notes?
Not necessarily.
Okay,
No.
because last time I tried to follow the exercise on Monday and it wasn't on the designated page that you mentioned on Monday.
Really?
Yes.
If I mention that it's in the notes, then it should be in the notes. Maybe
It's on there. It's just on a different page for us than it is for you, which I discovered after searching through.
Okay.
So it is on the lecture notes though, right?
Yeah, if I tell you it's in the lecture notes, then it should be in the lecture notes.
It's usually like 5 or 6 pages off than what she says.
Gotcha. Because I was trying to